Hi, everybody. Welcome to room number 5. We're excited to have you here and excited to have Connor Jensen with us. He's going to be talking to us about a year with a go. So with that, Connor, you have the floor.
Great. Thanks, Greg. Hello, everybody. Thanks for stopping by room 5 today to hear about my year with Go. I'm excited to share with you. I've really loved learning Go over the past year, and because of that excitement that I've had for it, I thought it'd be great to kind of share my experiences with you all. So let's get into it. Currently, I'm a software engineer at Simple Nexus, and so let's get into this. So the purpose of this talk, it's not to be a comprehensive guide in how to write Go or anything like that. It's just a brief background in Go, and then some of these lessons that I've learned through my past year with Go, and I'm going to call them signposts. So hopefully one of these signposts sticks in your head, and when you decide to learn Go, maybe in the next week or month or so, you can recall back one of these signposts, and maybe that will help you get past your sticking points when learning Go. So that's the purpose of the talk. Like I said, it's not supposed to be an exhaustive tutorial or anything. So if you are confused by some of the code I'm going to be showing or have questions, feel free to send those in Slack or in LiveSwarm, and then I can answer those at the end. And don't feel bad if you're not understanding certain pieces of this talk. So let's start with a brief background in why you might want to learn Go. So if you're at this talk, you're probably already interested in learning Go. So you probably already have at least one reason that you want to learn Go, but here's a couple more for you if you need some. We'll start off with the career opportunities in Go. It's a thriving job market for Go jobs. They're high paying. Go is statically typed, which in my opinion is a great reason to learn Go. I just love the features and benefits that a statically typed language offers. It's very explicit. It's got a minimal syntax, which is nice. It makes it easy to pick up, and it makes it easy to read other people's Go code. It's got excellent testing support, which is very important if you're into doing TDD and writing good unit and integration tests. It's got a great standard library as well. It lets you do a lot of things right out of the box, like starting a server or just doing a lot of CSV parsing, stuff like that. It's also got a very helpful community, lots of good podcasts and books, YouTube channels, and I think it's just fun to write. It's really clicked in my head, and I really enjoy writing in Go. So hopefully one of these reasons resonated with you and made you want to learn Go even more than you already do. So let's talk about the career opportunities real quick. I did a job search just on Glassdoor and Indeed.com, just a quick one for Go developer roles. And on October 16th, there were 2,480 roles on Indeed and 3,219 on Glassdoor. So that's a great sign. Lots of great opportunities in the field if you do decide to pick up Go as a language. In the 2020 Stack Overflow survey, Go was actually ranked number 3 in most wanted languages. That means developers who are not using the technology but have expressed an interest in learning it and developing with it. That's a great sign. That means people are going to be coming into the Go ecosystem, and more companies are going to be adopting it. It was also ranked the 5th most loved language, just behind Kotlin. So that's a great sign. People who are using Go are going to be sticking around and continuing to use it in the future, bringing up new projects and just growing the ecosystem in general. So yeah, developers love Go. We got the cute little gopher here, and personally, I feel this way about the gopher. Every time I see it, I just think, man, I love writing in Go, and I'm glad that I took the time and had the opportunity to learn it and use it. Another reason you might want to learn Go is Go developers are paid very well. So this is just a median of the 7,920 responses. for US-based Go developers, and it ranks right up there as number 2 on that list. That could have a lot to do, don't read too much into that, could have a lot to do with just the areas that Go is used in a lot. It's mostly used in the West Coast and kind of areas with higher living expenses. So that might have something to do with it, but still, it's a good sign. Go is statically typed, like I mentioned. So here's a quick example of the type system in Go. You can see here we define an example integer and we tell it that it's going to be holding an int. And from that point forward, it's only going to be able to store integers in this example integer variable. Go has some nice support for inferring types, which is kind of the best of both worlds. You can just declare a variable, and Go is going to say, okay, he's trying to store a string in this variable example string. So from this point forward, we're going to say only strings are allowed in this variable. And then just another quick example with an array of strings. They all have to be strings in this array. So don't worry too much about this code. I'm just showing this to you just to give you a primer and some of the reasons why Go is a good language to learn. If you're coming from a dynamically typed language such as Python, Ruby, or JavaScript, it can take some getting used to. So if you're worried about that, just know it takes a second to get used to, but it's the benefits of a statically typed language, I think, are worth it. Just the errors you get at compile time, the confidence that it provides, some of the the built-in editor autocomplete stuff, it just works a lot better in a language that's statically typed. So I think those are just great reasons that statically typed languages are beneficial. Go is very explicit, which was a huge interest to me because sometimes with magic, things are taken care of for you. Programming languages or frameworks that do a lot for you, it can be confusing as to what they're actually doing. And in my mind, I'm the type of person that I want to know what's going on. And that's a bad thing sometimes because I can just keep going down the rabbit hole and just, it never ends. You know, you have to stop somewhere. There's this meme, I wish I would have put it on, but this guy asks a question, you know, about electrons, and then he gets an answer and he asks a follow-up question, and eventually they get down to just like the lowest level physics you could possibly go, which obviously you can keep going from there. But anyway, quick anecdote, but Go is very explicit, which means a lot of times I'm able to understand exactly what's going on just by reading the code. I don't have to infer a lot of things, just and there's not a lot of magic going on here. So we can see that explicitness in the imports right here. We're going to import every package that we need at the top of the file. And this is standard, just how it's done in every Go file. So that's really great. You can see we're only ever using the FMT package and the time package in this file. And the second explicit thing, example of how explicit Go is with errors. So a lot of functions, this is just a method call right here, time.parse. This parse method is returning an error as the last argument, which is very explicitly returned, and you as the developer have to handle that in some way. In this case, we're just checking if it's not nil, we're just going to panic. So I really like that. There's not a lot of magic with errors bubbling up or anything. They're passed just from one function to the next as values, which makes it really simple and easy to see what's going on in the code. It also has great built-in testing support. You don't need to install extra libraries or anything to test your code. You can if you want. There's a lot of good third-party testing libraries, but built in the standard library are some great functions for testing, as well as running benchmarks. Here's some examples of the excellent community that Go has. And this is a really good podcast I would recommend called Go Time. There's the Go forums that people are really helpful. I've asked a lot of questions and answered some on the forum. People are always willing to help. And there's many great books that you can look into about Go. This one was actually written by Brian Kernahan and Alan Donovan, and these guys, at least Brian, wrote the seminal book on the C programming language. So I would definitely recommend this book if you're interested in learning Go. So in short, I hope that wasn't too exhaustive. I hope I didn't bore you too much with that, but yes, I think Go is worth learning because of those reasons I listed in the previous slides. And hopefully at this point, you think Go is worth learning too. So if you've decided to learn Go, I'm gonna now talk about some of the concepts that I struggled with the most. And this is just my personal experience. You may not struggle with these concepts at all, which will be great, or you may struggle with them like I did. If you do struggle with them, then hopefully you can refer back to this talk. One of these concepts I talk about will stick in your head, and you'll be able to quickly move past that hurdle that's blocking you from developing with Go. So one of the first things that confused me when I first started writing Go is, right, I installed it. I had the Go tool on my command line. I thought I was ready to go, and then I just wasn't sure, where am I going to put all my Go code, right? So if you've started Go recently, you probably have Go version 1.13 or higher, which means you're going to be using module mode. Now, module mode, the community kind of transitioned to modules over the past 1.5 to 2 years. But when I started, it was still very much in that transition period. So you're gonna be writing your code anywhere you want on your local computer. As long as you're writing in a Go module, your module is going to be able to find third-party packages that you install, and you're going to be able to use those in your source code, and you're going to be able to compile and run your Go program just fine. So this is pretty nice. It's going to be less confusing for people who are starting Go today or moving forward into the future. Keep in mind that you have a Go path when you install Go, and this is defaulted to your home directory and then a folder called /go. And this comes into play in my next slide. So like I said, because you're probably using module mode, you'll be able to put your code anywhere, which is a great benefit. So when I started using Go though, you had to put your code in the Go path /src directory in order for everything to work correctly. And that was just slightly confusing to me. I never understood why, at least for the first couple months, why my code had to go in this specific magic directory. But it's great that now you don't have to put it there. You can put it wherever you want. So next thing that confused me was now I have my code, and it's in any folder that I want on my local computer. I've run go mod init, which if we go back a few slides, was just right here. Use go mod init to initialize a module. So I've used that command, which means I can now write my Go code, and everything's going to work correctly. So you see I have my go mod file in the Explorer. I have my main.go. This is just a standard way to set up a Go project. And then I also have this ctime package, which is a package in Go is just a folder. And in that folder, you can have files, and all those files are going to be part of the same package. In this case, this package is called ctime. So I want to use a function that I've defined in ctime, which is great. So I was confused when I was first writing Go code in module mode. I was saying, okay, where does my root path start? So I know I'm currently in main.go, and I want to import ctime. So I was thinking maybe, coming from JavaScript or something, I'd use some form of dot slash or dot slash to do a relative import, but that's actually not how it's done. You're going to want to use the name of your module, which you've defined, and I'll show you this on the next slide, which you've defined in your go mod file as the prefix. You can see right here, this would be the prefix or my module name. And then this, so right here, example.com/example project. And then this ctime is actually my package that I want to import from my local file structure. So once I've imported that, I can then use it, and it's just defaults to whatever name is after the last slash. That's the default name. So I would just refer to it as seedtime, and then I can use any method that's defined in that package. So let me show you this example. This makes it easier to see in some respects, also more difficult because the syntax here is kind of strange. Basically, this is 3 files on one. This is 3 separate files in one file. So we have the package main right here, which is the main package. We have a Go mod file, which is just this one line, line 9. And then we have a separate package called greeter, which is this line 13, 15, 16, and 17. So this lets you see it a little bit easier. It's just all on one page here. So I have my main method where I want to use greeter.hello cool data and dev people, which is defined down here in the greeter package. And here's my module name. This is the name of my module. So you can see up here when I import it, I use my module name and then the path to my package, which in this case is just /greeter. So this was actually quite confusing to me when I first started, and it wasn't directly obvious. It took me some Googling. I remember specifically sitting here at my computer trying to use modules, and I was just like, how do I import my own packages that I've defined? And it took me a solid 15, 20 minutes of Googling to find that out. So when you're sitting at your computer and you're writing some modules, you're writing a Go module, and you want to import some of your packages, just remember that. Use the name of your module that's defined in your go.mod file as the prefix, and then just go down the path from there, however nested your package happens to be. Next thing that was confusing to me was remote modules. So we were just talking about importing a module, we were talking about importing a package from my local file system that I've written and is on my local computer. What this is referring to is pulling some repo down from, let's say, GitHub, or if you're familiar, like NPM or something, using a third-party package that's been written and pulling that down and using it in your source code. So it's super easy to do this in module mode with Go. You basically just put the file, you put the path to the module that you want to use at the top of your file in that imports block. And then whenever you run any of these commands, go install, go build, or go run, it'll automatically download what you've imported, save the version number and everything in your go.mod file, so it's not gonna, you're not gonna lose track of what version you're using. And then it's gonna put it in this go path /pkg/mod, which it's good to know that's where all your packages are gonna go. And you'll be able to import those by just using the path that starts at this /pkg/mod. So you won't have to prefix it with this go path /pkg/mod. You can just start your path directly at the next folder after that /mod. And I'll show you that in the next upcoming slides. So for example, if I wanted to use this cron library written by Rob Fig, all I would have to do is copy this string, put it at the top of my file, run go build or go run, and that's going to download it into my go path /pkg/mod directory. And then I can just refer to it by the name after the final /. So I can just say cron.new and use that in my source code. So yeah, keep in mind that when you're importing local modules, this prefix right here is going to be the name of your module. When you're using external modules, third-party modules that you're getting from GitHub or some other source repository, you're just going to use the path to, you're going to use the import path that they've defined. It's usually just on the GitHub page that you use to import. So those are kind of the two differences. And it took me a second to realize, where the differences were when I'm importing a local package versus an external package. Okay, with static typing, I know a lot of people in data and a lot of developers as well use dynamic programming languages, Python, Ruby, JavaScript, to name a few. So I was like that as well. I used mostly JavaScript before Go, which is dynamically typed. So it took me a while to understand what a statically typed language meant, and some of the pluses and some of the minuses of using a statically typed language. So one of the big things to me that was pretty shocking was when I was working with HTTP requests and getting responses from REST APIs. I was used to just getting a big response from a REST API, and I could, use whatever pieces I wanted and throw away the rest. And it was pretty simple. It was easy. You just make the request, get a body back, and you're good to go. So with a statically typed language like Go, it's a little more complex to start it up. So you do need struct tags. I'm going to show you this, which even adds another layer of complexity. So let's say I want to make a request to an API, which will return a response that looks like this. So we have a first name, a last name. These are both just strings. We have an attributes, which is another nested object. And then we have a birth date, which is a time.time. And you'll notice here that the API that we're interacting with actually names their fields with underscores instead of camel case. So that's different than how we're using it right here. We have this capitalized letter. The first letter is capitalized of each word. So that's another thing to keep in mind. If you're working with an API, you have to define a JSON tag right here that will match what the API is sending you in order for you to properly put the data where it needs to go in your struct. And you can also notice that this nesting can get a little hairy. You'll have to put a person's attribute, and then you'll have to go create that object as well. If this person attributes had an object inside of it, you'd have to go make a third object and refer to that inside this person's attribute. So this was really a pretty big shift in how I was used to doing things. It took me a while to see why this approach was beneficial and to understand this approach. So the key takeaways I think I want you to be aware of when you're doing this is, if you want to access, if you want the JSON to be properly inserted into these structs, these are going to have to be capital. So these fields right here are going to have to be capital: first, last, attributes, birth. If this was a lowercase b, this time would always be the empty time. It would never get the proper time put in this field. That's one key takeaway. Another one are these JSON tags. You need to use these if the field name you're using is different from the field name that you're looking for in the JSON. So just to recap, static typing, fantastic for auto completion and in-editor documentation. It gives you great compile time errors, and the refactoring becomes easier because when you make a change, your compiler is going to help you understand where you need to change other places in the code base that you also need to change in order to keep things in sync. Quick example: if you change a variable to an integer, it's going to yell at you and tell you all the other places you're using that variable, and then you got to go update those so it's expecting an integer. So some of the downsides are slightly more setup when you're initially using structs. You have to define everything: the data type, the JSON struct tag, possibly a database struct tag, which is just going to add more time initially. And that just leads into the next point of prototyping is going to be slower. There's going to be a lot more setup when you're just prototyping a quick, if you just want to make a quick HTTP request, get a response back, look at some data, it's going to take more time to do that. So just keep that in mind, and don't fight it too much. I fought it a little bit when I first switched to Go, but don't try to fight it. Just accept that it's going to take slightly longer on the front end, but it's going to save you some time down the road, and it's going to save you some headache and some bugs that might come up if you weren't using a statically typed language. Okay, next thing I want to talk about that confused me was how Go handles errors. So most functions in Go will return an error as the final argument. It's always going to be the last argument that it returns. And so you need to check for that. A lot of times I'll see posts on the Go forums, or even I did this myself when I was first writing Go. Someone's just not checking the error, and they're saying, why isn't this working? You know, what's going on? And the whole time that error is just being ignored as the final return argument. And if they were to just print that error out or just panic on it or whatever, it would say right in that error message what's going on. So that took me a second to fully comprehend and realize, hey, it's my responsibility to look for these errors and handle them properly. There's not going to be, unless it panics, but if it doesn't panic, you know, my program's not going to help me out with this. It's not like this error is just going to raise an exception or something, which is going to bubble up and get caught eventually at the top level. It's like, it's your responsibility as a programmer to handle those errors. So yeah, that's the first thing I just want to say about errors that I was confused about. You should always handle your errors when a function returns one. And then what do you do with errors? So do you just keep returning them up the call stack? Eventually you'll have to, you know, log them somewhere or do something with them. You always want to wrap your error. And I struggled with this because it's just slightly confusing. You know, you return an error. If we look at this code, I'm sorry, it's quite long, but let's start down here at the bottom. So if you do thing 3, it's going to return an error. And then that error is going to be come out right here on line 23, which then it's your responsibility once again to explicitly check that error. And then you're going to have to return that error back up again and back up again until finally we're going to log it right here on line 9. So it took me a while to understand what I should be doing in these intermediate steps. So for example, on line 25 and line 17, I wasn't really sure, should I just be returning this error without touching it at all? Or do I need to be adding extra information? If I'm adding extra information, where do I do that? And by that, I mean, should I tag, you know, see failed to do thing 3. So I'm tagging the method that this error came from in this new error message. Should I be doing that here, or should I encode this do thing 3 in do thing 3 itself? These were just kind of things that I was wrestling with and I was a little confused about when I first started. But I think the accepted answer is tag it in the level above. So in the lowest level, just return what went wrong, and then as it bubbles up, you can add these tags on. You know, failed to do thing 3, and then in layer 1 you can say failed to do thing 2 because of failed to do thing 3, et cetera, et cetera. So just keep that in mind when using errors. You always want to attach some extra context to them as they go up the chain of methods. Yeah, so this is exactly what I was talking about, where to put extra information. And I think it's a good idea to put that information in the higher level as opposed to in the method itself. Hopefully that makes sense. If it doesn't, please ask me some questions about what I'm trying to get across here. Okay, so we'll move on to the pass by value and pass by reference relationship. So once again, in JavaScript or Ruby or Python, you're going to be passing by reference. So you're basically passing around, you could call them pointers to objects, but in Go, you're actually passing around values at all times. It uses like value semantics, right? So this comes into play, and this actually caught me out many times. I was making a change and it wasn't reflecting in a different part of my code, and I was confused, and it took me a second to really understand this. So this is a super basic example that you can see. This will be with using JavaScript. We have an object here. So when I make this object, what's really being stored in here, and I'm not a JavaScript expert, I'm not a Go expert either, but what's being stored in here is basically a reference to this object. So when I pass that into a function, I can mutate it. I can say x.name equals my name in reverse. And then when I log that in the function mutate, obviously it's going to be the reversed name, but also outside of this function, after I've called mutate, it's also going to reflect that change, which is different than how Go does it. Go is going to do it by value. So if I create a person right here, x equals person, this is the same as line 1 in my JavaScript example. And then I have a mutate function that takes in a person. When I mutate that person, inside the mutate function, we're going to see that change. We're going to see it flipped around. But outside of the function, we're not going to see that. Okay, see how it says name equals Connor still? So that means that that was passed by value. X was passed by value. Or in other words, mutate received a copy of X, and it didn't receive a pointer to X. In Go, you can, there's a syntax that allows you to pass a pointer. I'm not going to get into that, but just keep in mind that this is how Go does it. It does pass by value. And that might not make sense to you right now, but I'm going to show you another example that is pretty common, I think, mistake beginners make when writing Go. So if I have this array of strings, okay, and I loop through it, so this is just a range. Python, or if you're familiar, you know, it's just a range. It's going over every value. But the key here is I and val right here, these are passed by value. So that means that these are copies. Val, at least, is a copy of what is in this array. So if I was to mutate val, it's not going to be reflected in A. And we can see that right here. So if the index is 0, I'm just changing val to capital HELLO, printing out A 0, and you can see that it's still lowercase. Printing out val is uppercase. So that's a pretty common mistake beginners make. They try to mutate those variables, even though they're not references to the original value. They're actually a completely new copy of the value. And you can see also after the for loop, the entire array was unaffected by that the logic inside the range. So keep that in mind. That tripped me up many times, and it took me a couple times to really get that in my head. So hopefully you can use my mistakes and learn from my mistakes. Next thing I want to talk about is organizing your Go projects. Go is a relatively young language, and there's not as many conventions around Go and how to do things. And a good example of that, counterexample would be Rails. You know, it's been around for a while, and there's really well documented ways to do things in that framework. But Go doesn't really have that quite as much. So this kind of made me have an empty space in my head of where, how I should structure my projects. When I was making personal projects, small projects, I was really concerned about how I should structure those projects. So just keep in mind that when you're structuring a Go project, there's not really a correct way to do it. It's all going to be dependent on the size of your project, what it's doing, and just your personal style. So I wish I would have understood that earlier on, because it would have saved me a lot of refactoring work that I did in an attempt to do things the correct way, when in reality, the way I was doing it was just fine for what my project was, and there was no need to refactor it in a different way. So I'll just briefly discuss two of the most common approaches and some of the benefits and downsides of both. So the flat file is just really just everything's on that root level. And some of the benefits of this is it's just very easy to get going. You don't have to think about anything. You just plop a new file down and put some code in it, and you're good to go. You know, as long as it's part of the same package, you don't have to import anything. It's just, you're good. So this is great for beginners, and it's honestly a fine way to start. So just know that this is okay. It's not a bad thing. It's not a beginner thing. It's okay to do that when you're starting out, which I didn't realize. From the get-go, I wanted to do like the perfect, you know, nested file structure that had everything in the right place, but that's not really necessary. If you do start going down that route though, a great way to go is grouping things by kind of domain objects, as opposed to like a controller model view type situation. Kind of group things more by like the business domain that it's talking about. So, you know, you'd have a student's package, a teacher's package, grades, and those would all just handle things relating to those domain objects. So yeah, basically what I want to get across with this was I was very confused about project structure. I worried way too much about it, and I shouldn't have. So just do whatever you're doing, and then if your project starts getting traction and becomes a success and scales, then you might have to do some refactoring, but that's totally fine in the future to do that. One thing is that's also great about flat projects is it helps you avoid that circular dependency issue, which you don't want to be worrying about when you're just getting your feet wet with Go. Okay, so I hope this hasn't been too rapid fire. I apologize if it has. My main purpose is to just give you these signposts that you might be able to refer back to when you're learning Go. So don't worry about understanding everything. If you even remember one signpost and it's able to help you, I will consider that a success. I will consider this talk a success. So that's what I'm trying to help you do here. And hopefully so far you've picked up at least one signpost, and then you can use that while you're learning Go in the coming weeks or months. Okay. Interfaces are the next thing that were very confusing to me. I'm saving these till the end because they're just a confusing topic in general, even for someone who has experience with Go and has written in a lot of other statically typed languages. And so it's understandable that it would be confusing, but these are some of the things that kind of clicked in my head that helped me understand interfaces a little better. Go basically uses a response to type interface contract, which basically means that you don't have to explicitly say one of your structs or objects is a interface. Just by the behavior of your object, the method set that your object has or your struct has, it's going to implicitly become a value of certain interfaces. This is commonly known, as duck typing. If it walks like a duck and it talks like a duck, then it's a duck. So you can use it as a duck in your code. And this is what this sentence is referring to. If a structure responds to a certain method set, then implicitly satisfies this interface and becomes a value of that interface. This is an example, just the nature of interfaces and trying to give a concrete example. It just does require quite a bit of code. So hopefully this isn't too overwhelming, but let's start at the top and just work our way down. So just focus right here on line 5. I've defined an interface called a jumper, which is just basically a contract saying anything that has a method called jump that takes in no parameters and it returns an error is going to become a jumper just implicitly. I don't have to say that anywhere, it just becomes a jumper. So we define a struct called kangaroo, and then I give it a method jump that returns an error. So just from this line 11 through 13, just this method right here, I've already created, I've already made kangaroo a jumper implicitly, even though I haven't defined here, I haven't explicitly said kangaroo is a jumper. Just by giving it this method, it's become a jumper. Same thing down here. So grasshopper, it also became a jumper as soon as I defined a method that matched this this method set right here. This jump method, this method signature. And then down later in your code anywhere, you can just kind of use your jumper, and you don't care if it's a kangaroo or if it's a grasshopper, as long as it has a jump method, it's good to go and your code's going to work fine. And so this was pretty confusing for me when I first started. I was just a little concerned about, okay, well, what if I accidentally satisfy the method set of some other interface that's defined somewhere in the code base or something like that? And I mean, you could definitely do that. Like there might be another interface somewhere that also has just a jump method as its method set. And I would also be implicitly satisfying that interface, but it really doesn't matter. Doesn't come up too much that that's going to be a big issue. So yeah, just keep that in mind. I think really just focusing on the fact that method set matching a struct's method set, and then that struct becomes an interface. That's the bare bones, just as simple as I can make it. And hopefully that makes sense to you. And hopefully when you look back, you can use this as an example. So yeah, I hope you remember a signpost from this talk. I really do. I really want to help you guys learn Go, because I think it's a great language to learn. It's fun and it's a great community. So I want to encourage you to go out and learn Go, and in the process of learning Go, hopefully you can look back and think of, oh yeah, that guy in that talk said, you know, if I satisfy this interface's method set, then it becomes that interface, and hopefully one of those signposts will stick in your head. So yeah, thanks for attending my talk. I really appreciate it. And then I'm going to open it up to questions if anyone has any questions for me.
Hi, Connor. We have 3 questions. So the first 2 are from Ro. Can you post your slides somewhere?
Yes, of course.
What courses, books would you recommend for Go? So
Great
for example,
question.
Pluralsight, Coursera.
Yep, that's a great question. So I think what I would recommend for a very beginner course is going to be it's a course on Udemy. It's just like Coursera or Pluralsight. They have some pretty good deals on courses. You can usually find them for like 10, 15 bucks. But there's a guy on there, his name's Todd McLeod. It's TODD, and then I'm not sure how to spell McLeod, but if you Google Golang Todd McLeod, however you spell it, I'm sure it'll come up. And he has a bunch of great courses that are really good for beginners. That's what I started with. It just walks you through the basics of how to even declare a variable. So that's great. There's also a book called The Go Programming Language, which I showed in one of my first slides. That's really good too, but I wouldn't start with that because it's written by like this high level computer scientist who he breaks down a lot of the like nitty gritty of the language. But after you've gotten the basics down, it's a great book to go with and learn more of the intricacies of Go. Another awesome resource is called Arden Labs. It's a company that mostly does Go and Docker training videos. They have really good Go videos, and the course is pretty expensive, but if you go to O'Reilly Learn, you can make a free account. It gives you a 7-day free trial, and you can look up their course. It's called the Ultimate Go Programming Course. So yeah, I think those would be my main resources. But start with that Udemy course by Todd McLeod for sure.
And where will you be posting your slides?
Oh, I'm not 100% sure. I think I could post them in the Slack channel, possibly a link to them in the Slack channel
Okay.
for that Utah Geek Event Slack channel.
Mm-hmm. The other question we have is from Christopher. What tools do you use when writing Go code?
Oh, good question. Yeah. So I switched back between, I was used to VS Code. And so I started writing Go in VS Code. And actually that's a great place to start because a lot of people are already familiar with VS Code. I know JavaScript, a lot of people in that community use VS Code. So I would probably start with VS Code. Another reason is the language server that is written in order to do a lot of the auto completion and stuff like that is actually the implementation of that is really, really good in VS Code. I think it's even better than the other IDEs that are out there that support Go. The next most popular IDE is called Goland, which is a JetBrains. It's written by a company called JetBrains, and it's a great editor, but I think I even like the VS Code integration with Go a little better. So yeah, I would start with VS Code. And then as far as other tools, besides from editors, yeah, you don't need much else. There's a bunch of command line utilities that you can install that are pretty helpful when writing Go code, but it's slightly more advanced. There's one called Delve. It's a debugger. It lets you step through your code step by step. That's a good tool that you could install. But yeah, the nice thing about Go is it comes with a lot of stuff in the standard library and packages pre-installed, so you don't really need to do too much scavenging of tools from around the internet. A lot of it is provided for you in the standard library, so that's good. Yeah, hopefully that answered your question. Let me know if it didn't, if there's a specific tool set you want me to mention. There's a website called the Golang Playground, which is really nice to get up and running with Go. You just type in Golang Playground or Go Playground, it'll pull it up, and it's like an online interpreter that you can just write some Go code and try Go out really quick. So that's a good tool too. And you can share little code snippets with that as well. So thanks, great question.
Do we have any other questions for Connor? Please enter them now in Slido or the Slack channel. Okay, doesn't look like we have any other questions.
Cool.
Thank you,
Sounds
Connor.
good. Yeah, no problem. Thanks everyone for attending my talk. I really appreciate it. So